Okay, are there more interesting questions here? Yeah, if we jump to part C, find two sampling frequencies such that fs2, right, C right here, two sampling frequencies that are between 3 and 7, for which h of t aliases to g of t. It's the same kind of question, except now f sub s is between 3 and 7. So this means that we have to draw a slightly different picture, where the 3 is less than fs1, so it's somewhere under this triangle, and the 7 is greater than fs1, so it's maybe in some of the other triangles. And then you would have to consider a few different cases to get the answer, right? So you would draw your 3 on the left and you would draw your 7 on the right. Maybe the 3 is right here and the 7 is right here, and then try to figure out what f sub s is. Okay? And I think this one is way harder to do with the formulas. So again, use the picture, write it down, and use it.
So didn't the answer the polygon
I'm sorry?
Didn't the answer the polygon
Yeah, it turns out that one of the answers is the 4 that I got. That 4 is one of the answers. And the other answer is 5. So that comes in some other way. Okay, so yeah, try to do this question actually. Now that you've seen the technique. All right, so this is question. It's labeled 58. It's on the very last page. Okay, so we've done aliasing to death, I think, and we've done a little bit of quantization, probably enough. You've probably seen enough on quantization. I hope you asked for it, but I think we should spend our time on other topics now. Okay, so the other topics that I have here are flip-flops, counters, PWM, and multiplexers. There is, in contrast to aliasing, there is vast number of questions in here that relate to that. So I think what I might do is ask you guys for which question you want to do on, say, well, any of those. Flip-flops, counters, PWM, multiplexers. So are there any requests? Well, no, not like specific questions from here, because there are some easy ones, there are some harder ones. Yes. Oh, I did not do the third part. You didn't get the answers I got, 4 and 5. Okay, let me instead of spending time writing it out, let me these solutions are posted, but you can see them right here. Okay, so I didn't have enough space to derive the solutions 4 hz and 5 hz, so I did it at the bottom of the page. Right, so I drew the triangles, and I know that fs2 has to be between 3 and 7. So if I put 3 over here and 7 over here, right, then the fact that the distance between 3 and 7 is 4, that is the length of of the base of one of those triangles. So that makes this 4, and that's how I got that one. And for the other case, I put 3 over here and 7 over here, and then I could get that 5 is right in between. And that is the sampling rate, where the triangle touches down. Okay, so that's how I got my 4 and my 5. Yes? 55? Okay. Thank you. Okay, looks like a good one. So that's this one? Yes? Okay. Where's my stuff? All right. Okay, so this is a good question because it kind of hits a lot of the components that we were interested in. It's got a counter. It's got right here. It's got a comparator right here, and it's got a bunch of D flip-flops. So the question asks: the output of a 3-bit up counter is connected to the A input of the digital comparator, and then you've got a 3-bit serial in-shift register connected to the B of the comparator. Initially, all flip-flops are in 0 state, right? So that means that there are zeros, all the outputs there are zeros initially. And the input to the shift register is always high, right, indicated by that 1. So complete the timing diagram below. And what's given to you is the timing at time 0. All the values at time 0. So, so the counter, for example, is at all zeros right here. And what does a counter do, an up counter, 3-bit up counter do? It counts from 0 up to 7, and then it starts at 0 again, right? And so that's just working with the clock. There's nothing fancy. It's not being reset or you know, as you might see in other questions. So you know, we can actually write down the entire behavior of this counter going forward. So that's the first number it counts to is 1. And look, notice that the queues are arranged, you know, with most significant bit at the bottom and least significant bit at the top. So this is 1, then 2, then 3, 4, 5, 6, and 7. And we get up to 7. You know, at the next stage it would go back to 0, but that's all we have. So that that comes directly from the behavior of the counter. Now that you know the inputs D0, D1, and D2, they start off at 0. The values in the shift register. What happens to them in the next step?